Today we're looking at Glencoe Course 2 Math, Lesson 4.1 on terminating and repeating decimals. Chapter 4 is all about rational numbers. When we worked in Chapter 3, we were working with integers. That means anything that was positive or negative plus 0 that didn't have any extra bits or parts with it. Well, our rational numbers are those that have the little extra bits and the extra parts. That means we're looking at fractions and we're looking at decimals. Those fractions and those decimals could be negative. The rules that we use for integers apply in the exact same way to decimals and fractions. So if we multiply two negative numbers together as integers, it became a positive. If we multiply two fractions that are negative together, it will still be positive. Alright? Now, I also know that most of us would prefer to work with the decimal over a fraction any day of the week, correct?
No.
Okay. So we're going to start out this chapter talking about decimals. We're going to do the part that we like first, and then we'll finish up with fractions. So if we're looking at decimals, there's a couple things that we need to be aware of. First of all, if we look at page 263, we are looking at 3 new vocabulary words. The first is a repeating decimal. That is a decimal that repeats itself. That means it's the same over and over and over and over and over again, but it repeats until infinity. That doesn't mean that we have it twice. It doesn't mean that we have it 3 times and then it changes number. Oh no. It means that that number keeps repeating until infinity. So if this young man started writing, he wrote out that decimal. We found, we kept adding paper and paper and paper and paper and paper. And he wrote out that decimal from the day he could write until the day that he died. Then someone else picked up the pencil and they kept writing it until the day that they died. And so on and so on and so on and so on and so forth. We can keep adding more paper.
Be quiet.
But it didn't matter how many generations of people kept writing this, it would still keep going. It would never end. It would never end. Now, there's 2 different ways that we can write that number that keeps on repeating until infinity and beyond. One way is what we call standard notation. That says we write the decimal with the repetition. We write the repetition 3 times. So that means that the 3 is the only thing that repeats. And then we add 3 dots after it. Okay? That's what we call more of a standard notation. You write the repetition 3 times, then 3 dots after it.
So it's like multiplying?
No. We're not multiplying anything. We're just rewriting our number in a different way. Okay? The other way that we can write this is what we call bar notation. Bar notation means that we write a line or a bar above the value that repeats. So, if we wrote this in bar notation, we would have 0.3 with a line above the 3. That is bar notation. That says that 3 keeps going on forever and ever 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 and ever.
So it never ends?
Correct. It will never end. Okay? Now, the whole decimal doesn't always repeat. Sometimes we just have part of it that repeats. So if we had something like 0.47666666, no honey, it's just a number. If we wrote that in bar notation, we have the bar over just a 6. If you put the bar over the whole thing, then that would say that we had 0.476, 476, 476. So, where the bar is located matters. Paying attention to what I'm telling you right now matters. So, having the bar over just the 6 means this. If we put the bar over everything, it means this. Those are not the same thing. When we are working with rational numbers, we have to pay attention to details. Even details like the length of a line. That matters. Okay. Let's look at what it looks like when we have a terminating decimal. That means a decimal that will end. The Terminator in that movie, he ended things. He made things stop. He terminated them. Okay? If someone is terminated from their job, that means that their time with that position at that job stops. Okay? If we have a terminating decimal, that means that that decimal will stop. And it will not go on forever and ever 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 and ever. So if we look at, I want to do 2 examples with you. The first one we're going to do is example 3. Example 3 gives us 5 3/4. And we need to write this as a decimal. To write 5 3/4 as a decimal, there's 2 ways that we can do it. I'm going to show you the easy way. Okay? Because as we know, mathematicians, we like to be lazy. So if I can show you one way that will work every single time, no matter what, you want to learn that way?
Yes.
Okay. The other option says you learn 2 different ways to do this, and one of them only works half the time.
Oh yeah, 2.
So let's learn the one way that works every single time, because it's also easier. Okay? Yes.
But what if you want to learn 2 of them,
Then see me after class.
Okay.
So basically, we make it longer.
No. By doing this the one way that works every single time,
So if it's short, we'll make it shorter.
what happens, the way that I show you, we can use every single time we need to take a fraction and write it as a decimal. The way that I show you to do this also works when I let you have a calculator. You can do it in a calculator. The same way. The other way that it can be done says that we need to find an equivalent fraction and then convert it to a decimal. That way it only works if something is a factor of 100 and a calculator won't help you that way. So I'm going to show you the one way that works every single time that also works if I gave you a calculator. Okay?
So if we use a calculator, it won't help us?
With the second way that we're not going to do, yes.
So that way...
The way that I show you, when I let you have a calculator, the calculator can help.
When that one, you was making it shorter.
Honey, I haven't done anything yet.
So that's
All I've done so far is write the problem. And then we had some questions and conversation and stuff. So we haven't gone any further yet. So we have 5 3/4. The 5 is going to go in front of my decimal point. That's a whole value. So we're going to go ahead and write down our 5 and a decimal point. Correct? Yes.
So if it was 6 before, we'll put a decimal.
We'd go 6 decimal point. Yep.
But why don't we put a decimal?
Because we're writing 5 3/4 as a decimal. Okay. Now to take the 3/4 and write it as a decimal, here's what we need to do. We're going to take 3 and 4 when we divide it.
0.
Numerator goes inside the house, denominator goes outside the house. Okay? Top number goes inside, bottom number goes outside. Did we do this when we were working with fractions and we had to simplify into mixed numbers?
No.
Yes. Okay? So, what we're going to do here, instead of taking and putting what we would have as a remainder into a fraction, we're going to take the fraction and turn it into a decimal. Can 4 go into 3?
Yes.
No.
No. No, 4 cannot go into 3. So I'm going to add a decimal point and a 0. Can 4 go into 30?
Yes.
Okay.
Yes.
4.
No.
4 can go into 30 6 times. You think it's 7?
Yeah.
No, it's 6 times.
It is 7.
Yeah.
It's 20.
Yeah.
It's 20.
It is 7.
7, I swear.
7 times 4 is 28. Just seeing if you guys are paying attention. 30 minus 28 is 2.
And add the decimal.
No.
You gotta add another 0.
You need to stop talking.
Why didn't you say 14 was 2? Oh, never mind.
We need to add a 0, bring it down. 4 goes into 20 5 times. 5 times 4 is 20. I subtract and I get 0. Now, I need a decimal point somewhere in my work. This decimal point comes straight up.
Well, you put
So,
you put 20 because what again?
because 5 times 4 equals 20.
Okay. And you got 0.
Because I added a 0 and I brought it down.
And you got 0.75.
Why don't you push
Okay.
it down?
What?
Why'd you push it up?
Why did I bring the decimal point up? Because that's where the decimal point goes in our answer.
So that's the answer?
Not quite. What we need to do, we need to combine the 5 whole with my decimal of 0.75. When we combine them, the 2 decimal points overlap. So we end up with 5.75.
Oh, that's easy.
Questions by a raise of hand.
No, man. No, man.
Wait,
Okay.
Can I just ask an example?
Ladies and gentlemen, we're going to do one more example. We're going to show you how to reverse it.
Reverse.
That means I'm going to show you how to go from a decimal to the fraction. Please remember that you are going to be that this is being uploaded.
What?
Mhm.
Is it gonna be edited?
How can I edit that out, dear?
Silence.
I edited it.
So, it'll stay up.
Oh, I just gotta see.
It don't even take me a minute to copy it.
It'll say that.
We're going to look at example 7. Example 7 gives us decimal equivalents for the total number of fish in an aquarium. So it took a ratio of fish, wrote it as a decimal, now we need to get it back into the form of a fraction. If we look at goldfish, goldfish was done for us, so I would like to look instead at guppies, okay? Alright, we're looking at the number. We're trying to find the fraction of the fish tank that is filled with guppies. We start out with 0.25. When we we convert from a decimal to a fraction, we're going to take this decimal point. Think of it like a line that's all curled up. We're going to uncurl the line and that becomes our fraction bar. With a fraction bar, in the denominator we need a 1. I have 2 places. I have 2 decimal places, so that means that I need 2 zeros.
You gonna put on this?
The rest of the number becomes our numerator. And then we simplify our fraction. 25 can go into 100 4 times, so that means we can simplify this to 1/4. Does anyone have any questions?
Yeah, I got you.
Yes, sir.
On example 3, do the decimal always have to go up 1? Like, it just have to go up?
What? The decimal point always
Yeah.
moves up? Yes.
What was my other I forgot my other question.
Okay. Yes. When we're doing our long division, as soon as we add a 0, we have to add a decimal point.
I know.
That decimal point is going to go up.
Yeah, I ain't know if it always go up.
Always, every time. Other questions? Yes. Thank you.